All right, here's your lesson on zeros and graphing polynomials, and I hope this is helpful. And I'm going to open up another window on Desmos soon. So first, zeros, I want you to write this down, are x-intercepts. They're called zeros because when you plug that number in, the answer is 0, the y-coordinate. That's why it's called zeros. So the point at which the function intersects the x-axis. So where it's touching the x-axis, a polynomial of degree n can have at most that many real zeros. So the degree tells you how many zeros they could have. An even degree polynomial has an even or no zeros. An odd one has odd number of zeros. So there might be.
Good afternoon, module students and staff. At this time, please release all fourth quarter honor roll recipients to the gym for a celebratory rally in their honor. Students, please make your way to the gym through the large swing gates between the 500 and 600.
All right, I'm going to.
All students must be wearing their ID cards and bring their belongings with them. Staff, please monitor your students as they leave the classrooms to ensure that students are wearing their IDs.
All right, so in order to understand the zeros, I'm going to factor this if I can. And I can also do it by graphing. But I'm going to factor out a common factor. There's an x in each term. That's what's left over. And then what's left is a trinomial, basic. Two numbers that multiply to -2 and add to 1. So +2 and -1 factor it. So I'm going to do that. Now, to understand the zeros here, I'm also going to understand this. So I'm going to, you can take each factor and make it equal to 0 and solve it as an equation. So it's called a zero because that number makes the equation 0. So if I just take x and make it equal to 0, boom, there is an x-intercept. I'm going to put that on my graph. I'm going to do it in red. So I'm going to find 0. That's right in the middle. So second factor, I make that equal to 0. And then if I solve it, the inverse of adding 2 to get x by itself, I'm going to subtract 2. So here's a second x-intercept. So if I plug -2 into this equation, the answer would be 0. That creates an x-intercept. I'm going to go -2. And I'm going to add 1. And there it is. Now, I'm also going to add like the end behavior. I know it's odd and positive, so the right end goes up and the left end goes down. And then we can add a little bit in terms of the turning and stuff, but I just want to focus in on the x-intercepts and the end behavior. Now, for number 2, the only way to find these x-intercepts right now is actually graph and look off the graph. I can't factor 5 terms the way it looks. So I'm going to minimize this. And you can see behind here I have Desmos. So here are my 2 windows. So I'm going to type in, it's a long equation, but I'm going to do it. So -x to the 4th plus 4x cubed, subtract 2x squared, subtract 4x plus 3. All right, so there's my graph. Now, my turning points are here, but we're not asking for those turning points. We're asking here, where on the x-axis, where is the answer 0, the y value 0? So we have zeros at -1. I'm here, -1, at +1, and at +3. So I'm going to write that down. Zeros are -1, 1, and 3. Those are my x-intercepts. Now we also have might as well put them on. We have, this is actually a turning point at 1, 0, and an x-intercept. Here, I'm going to estimate where that is on the graph. That goes up to 4. All right, 1, 2, 3, 4. And the other one also goes up to 4. and then connect it together. So this is what it looks like, but I'm focused on where is it crossing or touching the x-axis from the graph, -1, +1, and 3. All right, linear factors of a polynomial are when you factor it out, like what I did above. So if I factor this, each one has an x. So I'm going to factor out an x first. Oops, that's a -15. Then it's a trinomial. So that's -15 and -2. So the two numbers that fit are -5 and 3. They multiply to -15 and add to -2. Now each factor is linear, and so these are called linear factors. X, x minus 5, x plus 3. If you take each one equal to 0, you'll have your 0. So if I take x equal to 0, that's it. Now, a linear factor and a 0, they're opposite numbers. So when I solve it, I have to add 5 when it's equal. So if I take x subtract 5 equal to 0, to get x by itself, I'm going to add 5. They're going to end up being opposite numbers. So instead of -5, the 0 is positive. So factors and zeros are opposite numbers. Just like here, +3, the 0 is going to be -3. That's because 5, take away 5, is 0. -3 plus 3, 0. That's why it's called a 0. So there's a connection, but they're not the same sign. They're opposites. All right, can we write this out and understand multiplicity of a 0 is the number of times a factor repeats. So if I look and factor this out, again, I'm going to factor out an x. And then again, there's going to be a trinomial. So if I factor out this trinomial, two numbers that multiply to 9 and add to -6, it's a repeated factor. So the multiplicity tells me how many times does this factor repeat. So x minus 3 repeats 2 times. X only repeats once. So what are the zeros in their multiplicity? So first, x equals 0. So if I plug in 0 for x and I multiply, the answer is 0. So if it's just x, then the 0 that comes from x is 0. So if you take this factor x, make it equal to 0 and solve it, you get your answer. Now, if I take the other factor and make it equal to 0 and I solve it, notice they're opposite numbers. So first of all, back to here, x has an odd exponent. So it's multiplicity of 1. So 0 is a 0 and it has a multiplicity of 1. The other 0, if you solve this, add 3, is 3, and it has a multiplicity of 2, which means it repeats twice. So the exponent tells me the multiplicity. So the factor and the exponent. So the factor gives me the 0, they're opposites. The exponent gives me the multiplicity. Now, how does the multiplicity affect the graph? So this is the same equation. So I'm just going to, again, write this out. And then I'm going to go to Desmos again. So what would happen if I type that into Desmos? What's the graph look like? So let's do that. So I'm going to type it in. It'd be great if you followed along and you typed in 2. Oh, I didn't mean to move this completely. Here. So I'm going to type in f at x equals. Both are the same. I'm just going to type in the factored form. It's a little shorter. And so I typed it in. You could type in the question. It's the same equation. And then I want you to look at the important points. So I want you to look. They have an x-intercept at 0, another x-intercept at 3, and a turning point at 1, 4. So if I connect this together, this is what it looks like. So if I said 0, remember I said 0 has a multiplicity of 1 and 3 has a multiplicity of 2. So I want you to notice if the multiplicity is an odd number, it crosses over. So what did I say again? If the exponent on the factor is an odd number, what happens? It crosses over. If the multiplicity of a 0 or that factor, if it's an even number, so with this even number, the 0 is 3. So at 3, it did not cross over. Instead, it bounced. So those are the two words we're going to use. If it has an odd exponent, it crosses. An even exponent, it's going to bounce and not cross over. So if the multiplicity is odd, then the graph crosses at that 0. If the multiplicity is even, then the graph bounces at that 0, but doesn't cross over. All right, let's go back here. So this one's nice because it's already factored. So I just have to look at each one and solve it. So I say, what makes this 0? So -7. Because -7 plus 7 is 0. What's the multiplicity? And because it's an even number, what is it going to do? It's going to bounce. Now the next one is a little trickier because it's not a simple linear because of that 2. So what happens if you have 2x plus 1? How would you solve it to figure out the 0? Is you have to do 2 steps. So instead of adding 1, you're going to subtract 1. Instead of multiplying, you're going to divide. So to get x by itself, I want you to notice you subtracted 1 and then divided by 2. So you could do that in your head. Subtract 1, divide by 2, and what's the 0? And what's the exponent that's invisible? It's 1. Because it's an odd number, it's going to cross there. And now the last one, x minus 4. If you make that equal to 0 and solve it, what number makes it? They're opposite numbers. It's going to be positive 4. What's the exponent? That's the multiplicity. It's an odd number, so it's going to bounce. All right, let's try that again. This one I got a factor. So what do they all have in common is an x squared. And then what's left over is x squared minus 2x subtract 8. So I took out x squared from each term. And then I'm going to keep factoring. Two numbers that multiply to -8 and add to -2 are -4 and +2. So I'm going to write down x squared and then x minus 4, x plus 2. So from here, I'm going to be able to fill in the chart. So x squared, if you took x squared and you made it equal to 0 and solve it, the answer is 0. But what's the exponent? Is it even or odd? It's even, right? It's 2. And because it's even, at 0, it's going to bounce. If I look at the next factor, if I made it equal to 0 and I solved it, you would add 4 and the answer would be +4. These are always opposite numbers. And the exponent you don't see is the multiplicity, which is 1. It's odd, so it's going to cross. So the second one, last one there, x plus 2. If you made it equal to 0 and solve it, they're opposite, right? So subtract 2, and they're opposite. The answer would be -2. Again, what exponent is on there is 1, and because it's an odd exponent, it's going to cross. All right, number 8. A polynomial function has a 0 at -6, multiplicity of 2, and 2 with a multiplicity of 1. Write a function that could be this. So we start with their opposite numbers. So -6, the opposite is +6. And then the multiplicity tells me the exponent. Again, 2 is a 0. So the opposite number would be x minus 2. The exponent is the multiplicity, which is 1. I don't need to put a 1 there, but it's there. And this equation matches. All right, turn your book. This is the same equation or not? Is number 7. Different equation. Okay, so I want you to turn your book here. And we are going to graph this together. And we're going to put it all together in terms of what's happening. So characteristics of a polynomial function. So the first thing I need to do here is be able to factor it so I know what the zeros are, as well as understanding it. So first thing I'm going to do actually is the end behavior. So is this odd or even? And is it positive or negative in front? So what's the end behavior here? That means the right end goes up and the left end goes down. So the right end is up and the left end is down. That's the first thing I recognize. What else could I do here? So these turning points and increasing, I need Desmos for. The parent is just the very first term, which is x cubed. So that's the most simple form of this, and we would call this a cubic because the degree is 3. We can write that down too. All right, next, I'm going to factor this. So if I factor this, I'm going to factor out an x, and then I'm going to draw and be able to use 8 and 6, draw an x. What two numbers multiply to 8 and add to 6? 4 and 2. So we have x, and we have 4, and we have 2 right here. So now I can do the 0. So if x means the 0 is a 0, and the exponent is 1, which means it's going to cross. It's odd. The next one is negative 4. The exponent on the factor is 1 again, so it's going to cross. It's an odd number. And then negative 2 makes it 0. Again, the exponent is 1, which is an odd number, so it's going to cross. So each one it's going to cross. So when I start the graph, I'm going to go 0, negative 4, and negative 2. And I know the right end goes up and the left end goes down. Now, we're also going to find and use Desmos to find the turning point. So I'm going to minimize this again. I'm going to type that into Desmos. So x cubed plus 6x squared plus 8x. And so I'm going to approximate the turning points. Notice the negative 4, negative 2, we already have that. So negative 3 and positive 3, I'm going to put on the graph. That's a maximum. So I'm going to call that a local max is negative 3 and positive 3. I'm just making them friendly. And then the minimum is that if I make it friendly, I round it, it's negative 1 and negative 3. And that's a minimum. It's a low turning point. And then I'm going to connect these together and make my graph. And notice it crosses over at each one, like we said. All right, the last part here. Where is it increasing and decreasing? So I find it easier to draw a number line. So I'm going to draw a number line that goes from negative infinity to infinity. That's my x-axis number line. The x coordinates are going to go on this number line of the turning points, which are negative 3 and negative 1, the x's. Then I follow the graph. The first part of the graph rises, that's plus. The next part of the graph falls, and then the last part of the graph rises again. So the plus signs are increasing. So that goes from negative infinity to negative 3 and from negative 1 to infinity. Those are my plus signs. Decreasing are my minus signs. So it decreases from negative 3 to negative 1. The domain, there's no restrictions. And this graph goes up forever and it goes down forever, all y values. This part we're not going to focus in on polynomials as much as we are on other units, but it's there, so I filled it out. But I don't want you to be focused in on that. I want to know, do you know if it's odd and positive? Do you know the end behavior? Can you factor it and tell me the zeros and if they cross or bounce? Could you type it into Desmos and find the turning points, list where it's increasing and decreasing, and put all the graph together? Pretty good, right? This is good math. This is completely pre-calculus. This is not your math 1 and 2 stuff at all. All right, turn the page. Let's try it again. So let's start here. And then when I need Desmos, I'll do it. So first thing I'm going to do is try to factor it. If it's not factorable, and it may not be. So if it's 4 terms. So I'm going to factor out an x squared. And then I'm going to factor out the number that goes into both is 4. It's not going to factor. And the reason it's not going to factor is because these don't match. So I'm going to go right into Desmos. And I'm going to graph it with Desmos. So let me do that. So let me change this. So I typed it into Desmos, and then what I'm interested in are the zeros. So let's write that down. So the zeros are at 2 and 6. I can tell at 2 it's even, right? At 2 it bounced. And at 6 it's odd, so it crossed at 6. So 2, it bounced, and at 6, it crossed. So I'm going to put that on, 2 and 6. And we have a turning point. So I'm going to have one turning point. I'm going to estimate where that is. So I'm going to call it 5 and negative 9. We have 2 turning points. So we have a max and a min. So our max is actually up here. Where it bounced is a turning point. So 2, 0 is a maximum. Whenever it bounces, it creates a turning point. And then the minimum, we're going to make a friendly number out of it, is 5 and negative 9. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to connect and make our graph. So can you graph the function, then write a description of the graph you just see, right? So I want us to include things like end behavior, odd and positive. So I noticed f of x was both odd and positive. So the end behavior was up to the right. It's okay to write this way. And down to the right, down to the left. Two zeros at 2 and 6. At 2, the graph bounced. At 6, the graph crossed. 2 turning points. Two, 0 is a local maximum. Five, negative 9 is the local minimum. The graph increases from, and if we want to know where it increases, it goes from negative infinity, it increases up to 2. It also increases from 5 on, and decreases in the middle from 2 to 5. So it increases up to 2, then it decreases, and then it increases again. And those are all the characteristics we're looking for in that graph. All right, let's do that again. And let's include all that detail when writing, okay? So this one I'm not going to be able to factor, so we're just going to type it in. So let's start there, and let's type it in. So we have f of x equals negative x to the fourth, negative 9x cubed, subtract 24x squared, subtract 16x. Now let's look at the graph. And I'm going to first look at the zeros. So we have zeros at negative 4. It bounced. I have one at negative 1. It crossed. And at 0, it crossed. I also have 3 turning points. So I'm going to get rid of this and this. So we have a maximum there and a maximum there. So we have a local max at negative 4, 0. And then I'm going to make that a friendly number. So we have another one at like negative 0.4. So might as well call it 0.3. Just before 0.3, right, is another maximum. A local minimum is down here. And it's negative 2, negative 9, just to make it a friendly number. And then we're good with this now. So now I'm going to put that on the graph. So negative 4, negative 1, and 0. Oh, this max was 0, negative 4. Sorry, I mixed it up. No? Or negative 4. No, negative 4, 0. I was right here. Sorry. Negative 4, 0. So that's a maximum. And 0, 3. It's really just before it. Then we have a minimum at negative 2, negative 9. And now I'm going to connect this all. So it bounces, and it crosses, crosses, and then down. So that's what the graph looks like. I'm just going to draw a number line to understand increasing and decreasing. So I'm going to use 0, negative 4, and negative 2. And put them in order. So the graph first rises, then it falls, then it rises, and then it falls. And then we're going to write this again. So what is the end behavior, right? So f of x is even and negative with the end behavior of the graph is down on both ends. Now the zeros. So the zeros are negative 4, negative 1, and 0. The graph bounces at negative 4 and crosses at negative 2 and 0. The graph has a turning point at 0, 3 and negative 4, 0. Those are maximums. And at negative 2, negative 9, which is a local minimum. The graph increases from negative infinity to negative 4 and negative 2 to 0. The graph decreases from negative 4 to negative 2 and 0 to infinity. And that every important part of that graph you wrote down. All right, let's type this in. All right, we're going to do 2 more of these. All right, let me minimize this. All right, so we have negative x cubed plus 15x squared minus 75x plus 125. All right, so let's look at the graph. So we have a 0 at 5, and it crosses. We have no turning points. So I'm going to go to 5. I'll draw what I see. And I'm going to write down what I know. So what do I know about the end behavior? I know it's negative or odd and negative. So f of x is odd and negative with the end behavior here. It's bigger. With the end behavior down on the right and up to the left. F of x has a 0 at 5 that crosses. F of x only decreases, no turning point. So it only goes in one direction, never turns. So if I look left to right, it only goes down. So f of x only decreases with no turning points. All right, let's look at the last one. So those are the important facts. The end behavior, zeros, turning points, increasing and decreasing. We covered that all. All right, last one here for the lesson. All right, let's type that in. So one more time, this is the last time for this video, I'm going to type in Desmos here. Make sure I typed it in right. Okay, and then I'm going to look at it. So these are the zeros. So I'm going to write those down too. There's 4 zeros. So I'm going to write that down. So negative 1, 0, and positive 1, they all bounce. And then the only one that, so they all cross. The only one that bounces is 3. Sorry, this is cross. This one, it bounces. So at negative 1, 0, and 1, they cross at each one. And then at 3, it bounces. The turning points. So the local max, where does it turn? So I'm going to get rid of these guys. So we have a turning point there. And where else do we have a turning point? There's another high turning point. We'll make it friendly. So 2 and 6. And then where are the minimums? Get rid of this one. We have 2 minimums. Make it as friendly as I can. And that's all I needed from Desmos. So I'm going to put those things on my graph. All right, so those are my points. Connect them and make my graph. And then I'll write my little statement to understand. So I know f of x has a degree of 5 and a leading coefficient of 1. So the end behavior goes up to the right and down to the left. F of x has zeros at -1, 0, 1, 3. The graph crosses at -1, 0, 1 and bounces at 3. Turning points, local maximums at, and we write down the local maximums and local minimums. F of x increases, and we'll write down the intervals we're doing. So the first graph, it increases to this turning point. It also increases from that turning point up to this turning point. And it increases from this turning point to infinity. So it has 3 areas where it increases, increases, increases. F of x decreases and goes down here. So we write down from this turning point down to this turning point. It also decreases from that turning point, which is 2, to 3. So we have the intervals where they increase and decrease, where the maximums and minimums are, where the graph crosses and bounces. We know that it is an odd degree with a positive leading coefficient, so the end behavior goes up to the right, down to the left. And we know where the zeros are and what happens. Awesome. All right, that was it. So Mr. G Math over and out. That was a long lesson. So whatever part you need to watch over again, you can. I'm proud of you that you got to the end of the lesson and you tried your best to listen and follow and write down. And we'll do more in class. All right, till next time.